In previous video, we obtained electric field due to straight line charge distribution. First on axis of wire and second one in perpendicular direction to the wire. Now suppose we have one more line charge distribution, but now it is not in form of straight wire. Suppose it is in form of curve. Here we have taken a curve of length, suppose L. Its radius is R and it makes angle theta at center. Now we want to find out electric field produced by this arc at center point O. So again, this is continuous charge distribution. Suppose its uniform linear charge density is lambda. So what we'll do, first we'll try to take a small segment of wire. So here we'll take a small segment of wire, for example this much segment of the wire. It has length dl and charge present on it is suppose dq. This segment is selected at angle phi from x-axis and it covers angle d phi at center. So if we draw direction of electric field due to this much segment here, this electric field will be in this direction. So this is electric field DE. Now this angle is phi, so here this angle will become phi. That means one component of electric field which is along the x-axis is DE cos phi, and along negative y-axis another component will obtain which is DE sin phi. So now if we want to find out total electric field produced by this wire at point O, first we will have to start with a small segment and we will try to find out magnitude of electric field first. So here DE is equal to K into dq, according to Coulomb's law, K into dq upon R square. R is distance of this segment from this point, which is small r, and small r is here radius of this particular curve, so it is constant. Now lambda is linear charge density, so lambda is equal to, now linear charge density lambda is equal to charge dq upon length dl. So dq will be equal to lambda into dl. Now if we convert this dl into angle d phi, then angle is equal to, angle d phi is equal to length dl, length of arc which is dl, divided by radius which is r. So dl will be equal to r into d phi. If we substitute this value over here, then dq will become lambda into r into d phi. So if we put this value of dq in our first equation, then we will get dE is equal to K into lambda into r d phi divided by, here it is r square, so r square, one r is cancelled, so dE is equal to K lambda upon r into d phi. So this is electric field due to small segment at point O. Now total electric field is integration of this electric field, but here total electric field will have two components. One component is along negative x-axis. So if we find out x-axis component Ex, then it will be integration of all the dE cos phi components, dE cos phi components. So this is integration. What is dE? it is k lambda upon r into d phi into cos phi. Now this wire starts from here where theta angle is 0, actually phi angle is 0, and it will go up to here where phi angle will be equal to this value theta. So we'll take lower limit as 0 and upper limit as theta, and if we integrate it, then k constant, lambda is constant, r we are taking out, integration of cos phi is sin phi, lower limit is 0 and upper limit is theta. So finally x component of electric field is equal to k lambda upon r into sin theta minus sin 0. Sin 0 is 0. So this is x component of electric field. Now similarly, we can also find out y component of electric field. So if we calculate y component, so electric field's y component is integration of dE sin phi. Now what is dE here? So dE is k lambda upon r into d phi. So dE is k lambda upon r into d phi into sin phi. Again lower limit from 0 to upper limit theta. So if we integrate it, k constant, lambda is also constant, r is constant. Integration of sin phi is minus cos phi. Lower limit is 0, upper limit is theta. So substituting upper limit and lower limit. So if we substitute upper limit and lower limit here, then we'll get E on y-axis is equal to k lambda upon r will remain as it is, k lambda upon r is as it is. Now upper limit is theta, so minus cos theta minus minus plus cos 0, and cos 0 is actually 1. So this is Ey is equal to k lambda upon r 1 minus cos theta. So now we have y component of electric field also. So total electric field produced at this point is in third quadrant. So in terms of x and y component, if we write, then E is equal to minus Ex caret I plus, or we can say minus Ey caret j. This both component x and y component will be negative because electric field is in third quadrant. So if we put up these two values here, then minus in bracket k lambda upon r sin theta plus k lambda upon r 1 minus cos theta. Here caret I component, this will have caret j component. So electric field E is minus k lambda upon r in bracket sin theta caret I plus 1 minus cos theta caret j. So finally we have electric field due to arc of angle theta at center of that particular arc. So this is one important formula to solve numericals related to arc. Even we can take some special cases of this particular calculation also. For example, if we take case 1, first case we'll take for half circle. Case 1, half circle. Suppose we have coordinate system like this, x-axis and y-axis. We have one wire which is in half circular form. It is uniformly charged. Linear charge density is, for example, lambda. At center, we want to find out electric field. Its radius is r. So in this particular case, electric field generated by this point will have this direction, and exactly at same angle in opposite side, electric field will be in this direction. So here parallel components or components along x-axis will be in opposite direction and they will cancel each other, and electric field's y-axis component will be added. So in this type of situation, resultant electric field should be only on y direction. If we want to find out total electric field at this point, then what we can do, we can use this formula directly. Here we have taken half circle, so theta will become 180 degree. So if we substitute theta is equal to 180 degree in this particular equation, then substituting in our equation number 3, then electric field will be minus k lambda upon r in bracket sine 180 degree caret I plus 1 minus cos 180 degree caret g. Okay, so this will be minus k lambda upon r in bracket sine 180 degree is 0 caret I plus 1 minus cos 180 degree is minus 1, so this will be minus 1 caret g. So here minus 1, that is 2, so final answer is minus 2k lambda upon r caret g. So this is electric field due to half circular wire at center of the curve. So here see, it is in the direction of negative y-axis only, that means x component is 0. So this was our first case. Similarly, we can take one more case where we'll take whole circular loop. Case 2, that is circular loop, and we want to find out electric field at the center of loop. Again we are taking coordinate system. Suppose we have one circular loop like this, it is uniformly charged, and we want to find out electric field at center. So this is uniformly charged circular loop and this is center point O. We want to find out electric field here. So this is regular figure. Charges are uniformly spread. So in that case, if we find out electric field due to this point, that will be in this direction. So we can find out one exactly opposite point which will create electric field in opposite direction. So these two electric fields will cancel each other. Similarly, suppose we want to find out electric field due to this point, that will be cancelled by electric field due to this point. So finally, due to this charge system, electric field at center will become 0 because this is one symmetric uniformly charged distribution system. Now suppose this value we want to find out by this method, then we already have equation. Here we have to take angle 360 degree instead of 180 degree because we have considered whole loop. So in this formula, if we place 360 degree over here, then if we solve them, this is minus k lambda upon r sine 360 sine 2 pi. Sine 2 pi is 0, so this will be 0 caret I plus cos 360 is 1. So 1 minus 1 is 0, so this will be again 0 caret g. So finally electric field is 0. So that means we can write that electric field at center due to uniformly charged loop is always 0.